Hi. In the last video, we've covered comparative statics in national income model for closed economy. Now we're going to just modify our results slightly in order to accommodate open economy, and we'll see what is the impact of this on our results. Okay, so first, just as before, we need to calculate the equilibrium. So we probably need to reduce the number of equations. Let's just say that we're going to have a system for just three variables: y, c, and inputs. Okay, so if I combine those two equations, I'm going to get that this is y equals c plus I0 plus G0 plus x0 minus inputs. Okay, here I'll have to make substitutions. So I'm substituting this over here and this over here, right? So I'm getting that this is c equals to a plus b times 1 minus t, right, times income, right? So now we have disposable income over here as well, so we need to substitute this equation to this equation and then again into the last one. So we will get that imports are equal to m times 1 minus t y, right? Look, we substitute t times y instead of t, then this instead of disposable income, then we get this expression over here and over here. Okay, next thing, let's just move all the endogenous variables to the right, exogenous to the left. So here we've got y minus c plus imports equals to I0 plus G0 plus x0. Over here we've got negative b 1 minus t times y plus c equals to a, and in the last one we've got negative m 1 minus t y plus imports equals to 0. So now, having done this move, we can easily put this system into matrix notation. Okay, so we've got 1 negative b 1 minus t, negative m 1 minus t. Then we've got negative 1, 1, 0, and then we've got 1, 0, 1. Okay, so here we have y, c, I, m equals to I0 plus G0 plus x0, a 0. Okay, so of course, next thing we need to do is to calculate the determinant and make sure that this determinant is different than 0. So we've got 1, then we've got 0, 0, then we've got plus m 1 minus t, and then we've got 0 and minus b times 1 minus t. Look, this result is a little bit different than what we had previously. I made this model slightly different in a way that here we've got disposable income. When we put this model in such a way, it has the advantage of showing better how this multiplier process works in open economy. Okay. Okay, and what do we know here? T, of course, is between 0 and 1. So 1 minus t must be between 0 and 1. This, again, as well. So here we've got MPC, marginal propensity to consume, that needs to be between 0 and 1. And here we have marginal propensity to import, which also needs to be between 0 and 1. So, products of these two needs to be between 0 and 1, and the same here. So, what do we get now? Look, 1 minus b times 1 minus t, again, must be between 0 and 1. And look, now we are adding to it an expression that is somewhere between 0 and 1, which means that this expression is clearly bigger than 0. However, we cannot be sure if this expression is actually between 0 and 1. But there is a thing that we can assume to make sure that this is the case. And we are going to assume that because this is a fact from reality, and actually it could be distorted in very small open economies, but this is not our subject. So we're going to assume that marginal propensity to consume is bigger than marginal propensity to import. In this circumstance, we can be 100% sure that this expression is actually somewhere between 0 and 1. Okay, so what do we do next? Of course, we need to find income. Today, just as in the previous video, this is the only thing that interests us. So we take a vector of exogenous terms and we replace the first column, right? So we have 0 plus I0 plus G0 plus X0, A0, negative 1, 1, 0, 1, 0, 1. Okay, this is quite easy, so we can just calculate it right away because it gives us I0 plus G0 plus X0, right, from here. Then we've got 0, 0, 0, 0, and plus A. Okay, so now we've got an expression for for equilibrium level of income, and it is A plus I0 plus G0 plus X0 all divided by 1 minus B times 1 minus T plus M1 minus T. Okay, so knowing all this, we can move to comparative static derivatives. And look, let's calculate one with respect to G0. But look, I hope you remember that it doesn't matter if I calculate this comparative static derivative with respect to A, I0, G0, or X0, I'm going to get exactly the same result. So, if I differentiate this, look, it's going to be the same outcome as before. Those are treated as constant, so the coefficient on G is 1 over the denominator. So we got that this is 1 over 1 minus B times 1 minus T plus M1 minus T. Okay, what can we say about this expression? Well, we clearly say that this expression is positive. Here we've got 1, we've actually shown that the bottom is positive. Okay, and now look, this is why I wanted to show you that the key assumption over here is that B is bigger than M. So marginal propensity to consume is bigger than marginal propensity to import. Because look what will happen over here if I'm going to take the common part out of these two expressions. 1 minus t. So I'm going to have 1. Let's just write it as plus 1 minus t times m minus b. Okay, now look, we can have here two possible cases. If it happens to be that m is bigger than b, this expression is going to be bigger than 1, right? Because look, if this outcome turns out to be positive, so if m is bigger than b, we will be adding a positive number. And look, if this would be the case, we could say that the comparative static over here is always somewhere between 0 and 1. Why? Because we divide 1 by a number that is clearly bigger than 1. However, if b and m are equal to one another, this expression is gone, right? Because they are equal, so this turns into 0. And our multiplier is equal to exactly 1. However, if we maintain the assumption that b is bigger than m, look, we will be subtracting, we will get negative outcome here, we will be subtracting something from 1, and this is what we are actually doing. And we can say in this case that this expression is bigger than 1. And again, this result is a key to understanding how the multiplier process works. Because look, again, this is a multiplier. Let's call it open economy multiplier. So what do we know about this open economy multiplier? Look, let's consider two cases. Let's compare those. We've got an open economy. No, let's start with closed economy. And here we've got open economy. Okay, now, what is the value of multiplier in open economy? Well, in closed economy, we remember, let's call it MC, and it's equal to 1 over 1 minus B times 1 minus T. In the open economy, we now know that this is MO. It's 1 divided by 1 minus B, 1 minus T, plus M times 1 minus T. Okay, what can we see right away? One of these expressions is clearly bigger than the other, and of course, this must be closed economy multiplier. Why? Look, here we are dividing by a number 1 minus b times 1 minus t. Here we are dividing by number 1 minus b times 1 minus t plus something extra. This m, marginal propensity to import, times 1 minus t. This means that right away the value of the multiplier in the open economy must be smaller, because we divide 1 by a bigger number, we get the smaller number as an alpha. Okay, let's do this on a very simple example. Let's just say that b is 0.9, t is 0.1, and m is 0.2. Okay, let's calculate the value of the multiplier in both cases. What do we have here? Here we've got 1 divided by 1 minus 0.9 times 0.9, right? So this is, oh, we had this one already. This is 1 minus 0.81, 1 over 0.19, which is approximately 5.26. If I'm not mistaken, yeah. Okay, now let's calculate the same thing over here. What do we get? Well, this part will be the same, right? We have 1 over 0.19, but here we've got an additional element. We've got 0.2 multiplied by 0.9, which gives us value of the multiplier 0.19 plus 0.18 is 1 over 0.37, which is approximately, let's write it as 2.7. Okay, so knowing this, we can clearly see that introduction of open economy into our model, so introduction of just exports and imports, has lowered the value of the multiplier in the economy. So look, we know that change in equilibrium level of income in the closed economy, right, is given by m closed, which is of course value of the comparative static derivative, times change in the level, for example, of government spending. Let's assume that it's 100. And what do we get? In our case, if government increases spending by 100 in a closed economy, GDP increases by 256. However, if I'm going to do the same exercise for open economy, and again, let's just say that government increases spending by 100, we see that equilibrium level of GDP increases by 270, which is half of what we get in closed economy. Now, the question is, why does this happen? Look, we can actually figure this out quite easily. How? Look, we already know how multiplier process works. Basically, if government increases spending in the economy by 100, government gives an opportunity for some company to make money. Then people from this company are also members of households. So they take part of this money, that is not going to the government, and they are spending it on other people's goods, other people's businesses. Then those people make money, and they spend part of it on other people's goods. So but of course, not all this money goes to the economy. Why? Because look, when we have income, part of this income goes to the customers in form of disposable income, and part of it goes to the government in form of tax revenues. How much goes to the government? T. Right? How much goes to the households? 1 minus T. Right? Then, what households can do with the money? They can spend it either on consumption or on savings. What part goes to consumption? Well, B. How much goes to savings? 1 minus B. And look, over here, with this line, we can track part of money that goes back into the economy. But not everything goes back, because part of it goes into government as the tax revenues, and part of it goes to households, stays with households in the form of savings. So this is the part that actually goes back into the economy. And look, this is how it works in closed economy. How does it work in open economy? Well, first, when we receive income, of course, again, part of it goes to the households, part of it goes to the government. And again, the ratios are the same. So here we've got the 1 minus T goes to the households, T goes to the government. And now, on what people can spend their money here, this is the key. Here, we actually see a third choice. Because households can spend it either on domestic consumption, on consumption of foreign goods, otherwise known as imports, or on savings. Now, how much households spend on consumption? Well, they spend, wrong color. They spend B, marginal propensity to consume. How much do they spend on imports? M, marginal propensity to import. How much they spend on savings? Well, the reminder, 1 minus B minus M. Of course, even in this outcome, we see that this might be problematic. In this example, it might seem very problematic, because you see that B is 0.9, M is 0.2, which is why we usually restrict those to be smaller than 1. In this case, we've got actually negative savings, so that with our example, with this example, actually, I was able to show you the big difference that it can make. But if those numbers usually should sum up to less than 1. So we should have something like B plus M is somewhere between 0 and 1. And of course, B being bigger than M, which we already said. Okay, but that is a digression. I just want to show you now what is happening in this one. Again, the income goes back to the economy, but part of it goes to the government. Now, what is important is that when we talk about consumption in open economy model, we talk about domestic consumption. So this is the spending of households on goods that were produced in our country, in our economy. Imports, however, work differently. Those are the goods that were produced outside. So actually, this is another source of outflow of the money out of our economy. So look, here, when we introduce actually imports, we've got a second source of outflow of the resources out of the economy, right? And because of that, we've got lower value of a multiplier. And look, it makes perfect sense. In this case, in the closed economy, when you were receiving income, you were spending part of it given by MPC, on domestic goods. Now, you spend part of it on domestic goods and part of it on foreign goods. So there is less opportunities for people from your own country to make money. And this is why multiplier in the open economy is simply lower than in closed economy. Okay, so again, we might say that we found another automatic stabilizer because M, marginal propensity to consume, is an automatic stabilizer. Now, can we somehow prove it? Actually, of course we can. Simply by calculating appropriate derivative. We should remember that equilibrium level of income is given by this expression. Now, so what is the value? So what happens to equilibrium level of income as marginal propensity to consume increases? Well, it's easy. You just need to calculate appropriate derivative, comparative static derivative, with respect to M. Okay, and look, we need to, of course, use the quotient rule, because M appears in the bottom. So we start by taking whatever is in the denominator and putting it in squares. And now, what will we have on the top? There's no M here. So first part is 0, so we've got minus first expression A plus I0 plus G0 plus X0 times derivative of this with respect to M, which is simply 1 minus t. And look, we clearly see that all those are positive. This is positive, this is clearly positive, we've got minus, and it's lower than 0. So, just by calculating this derivative, we actually demonstrated that the higher the marginal propensity to import, the lower the equilibrium level of income. Okay, and look, we could do exactly the same thing, just as we did before for B and for T. Let's just do it and see what we got. Let's start now with marginal propensity to consume. And, well, we're going to have all these expressions looking very similar, especially exactly the same when it comes to the bottom. Then it always starts with minus the first expression on the top. Okay, and now, derivative of this with respect to b is negative 1 minus t, right? So 1 minus t over here, minus is gone. We see that this outcome is positive. So now we know that the higher the marginal propensity to consume, the higher the equilibrium level of GDP. And finally, we can do the same thing for taxes. Okay, and we start exactly the same. And now, okay, we need to differentiate this with respect to taxes. So like, first part, out of this, coefficient is just b, right? Minus and minus gives us plus, and the coefficient on t from this is just b. Out of here, it's negative m. And now again, we see that under the assumption that b is bigger than m, right? Value of this expression is negative. Okay, so this is it about national income model and comparative statics of national income model with open economy. In the next video, we're going to go back to Leontiev model. See you in the next video.